So for problem number 2, for the figure shown below, if the area of the tank is 0.5 meters squared and the hydraulic conductivity of sand is 0.1 centimeter per second, what is the magnitude and the direction of the rate of seepage? If the value of H is equal to 1 point, then another question is, if the value of H is equal to 1.2 m, will boiling occur? Why? What should be the value of H to cause boiling? So now, here is the figure. So based on this figure, you are able to put this given here. The void ratio is equal to 0.55, then the specific gravity is 2.68, and the head loss is 1.2 m, and also its length is for the sand is also 2 meters. Then its area is 0.5 meters squared. Then its hydraulic conductivity is equal to 0.1 centimeter per second, but we will convert into meters. Then the value of the hydraulic conductivity into meters is 0.001 meter per second. Then the first question is, what is the magnitude and the direction of the rate of seepage? So as what I have learned for the previous topic, the formula for the magnitude of the rate, for getting the value of magnitude of the rate of seepage is Q, which is the rate of seepage, is equal to the hydraulic conductivity times its Q times its hydraulic conductivity times hydraulic gradient times its area. Then since we have the hydraulic conductivity and the area is given, so the first thing that is unknown is the hydraulic gradient. So for the formula for getting the hydraulic gradient is the head loss over the length. So since the head loss is given, which is 1.2 meter, and also the length is given also, which is 2 meters, the length for the sand, so we have found out that the hydraulic gradient is equal to 0.6 meter. So now, since it is the values in order to get the seepage is complete na, so simply substitute these values. We have here the hydraulic conductivity is equal to 0.001 times 0.6 times 0.5. Then we have found out that the value for the magnitude of the rate of seepage is equal to 0.003 meter cube per second. So for the direction, we have to calculate the total head at point B is equal to 2 plus 1 plus 1.2 is equal to 4.2 meter. Then the total head at point A is equal to 2 plus 1 is equal to 3 meter. Since the total head at point B is greater than the total head point A, so we can say that the direction of the rate of seepage is upward. So for question letter B, if the value of H is equal to 1.2 m, will boiling occur? So let us first calculate the hydraulic gradient. Since the it was stated that it was noted that if the hydraulic gradient is equal to the critical hydraulic gradient, if they are equal, so the boiling will occur. So let us test this value first. So now the value for the hydraulic gradient that nakuha na to daan is 0.6 meter, ay 0.6. So the critical hydraulic gradient, the formula for the critical hydraulic gradient is equal to the specific gravity minus 1 over 1 plus the void ratio. Then we have the specific gravity is already given, 2.68 minus 1 over 1 plus also the void ratio is given, so 0.55. So we have here the critical hydraulic gradient is equal to 1.084. So since dili equal ang what we call is the hydraulic gradient and the critical hydraulic gradient, so we can say that it is the boiling will not occur since the critical hydraulic gradient is greater than the hydraulic gradient. So for the last question, the question letter C, what should be the value of H to cause boiling? So for what I have said earlier nga kung equal ang hydraulic gradient ug ang critical hydraulic gradient mo na ang mag-cause of boiling. So since problem kay nagpangita naman kung kano sa mag-cause of boiling, so atong i-set this as sila nga equal. So the also mag-cause of boiling kung ang hydraulic gradient kay greater than the critical hydraulic gradient. So now, so same na sila formula sa ang critical hydraulic gradient, same na formula sa hydraulic gradient. So it's equal to the head loss over the length, the height over the length. So reform this formula since we are atong makita kay H. So we have here the critical hydraulic gradient times the length. So since nakuha na to ang critical hydraulic gradient, which is equal to 1.084 times the length is equal to 2. So the value of H to cause boiling is equal to 2.168 meters. Thank you.